Okay, so today we're going to cover section 2 of chapter 11, and today we're going to find area of circles and area of a sector. So the first thing is the formula for area of a circle, and that is described as the area of a circle is pi times the square of the radius, or pi r squared. So that's your formula that you're going to memorize for the area of an entire circle. Next, we're going to define what area of a sector means. So a sector is a region bound by two radii and their intercepted arc of the circle. So the sector of this circle would be the yellow part. So it's like a piece of pizza or a piece of pie. Really, we could also say that the sector could also be the red part. So we have two sectors in this picture. A teeny tiny piece of pizza, so it could also be, let's say I draw this. So it's the sector, what we're doing is the sector is this part. It's like the whole piece of pizza. The arc length is the crust. Does that make sense? So a sector is just two radiuses or two radii form it, and then the arc, and it makes a piece of pie or a piece of pizza. All right, next is going to be the formula to find the area of that sector. So this is the ratio of the area of the sector of the circle to the area of the whole circle, pi r squared, which is equal to the ratio of the measure of the intercepted arc to 360. So just like yesterday, not all of our circles are going to have the letters A, B in them. So if you want to just memorize the generic form of this, you could say that the area of the sector, so area of the sector could be found by taking the measure of the arc over 360 times the area formula for the whole circle, which is pi r squared. So remember, a sector is only part of the circle. It's not the entire circle. Again, it would be like the area of a piece of pizza. So the next slide actually has 4 different examples. For all 4, we're going to use the same radius. The radius we're going to use is 3. Now, keep in mind that when we do other problems, the radius is going to change depending on the size of our circle. But for these 4 examples, we're going to use the same radius. The formula that we're going to use to find the area of the sector, again, remember, is the measure of the arc, which is what they're giving us, over 360 times our area of our circle, pi r squared. So to find the area of the arc, or the area of the sector, given an arc measure that's 50 degrees, we're going to do 50 over 360 times pi times radius squared. Now, the other class was confused with the simplifying, so I'm going to first show you how to do it without simplifying, and then I'm going to simplify it, because this would be the type of questions you get on your quiz, and you're leaving it in terms of pi. So what the other class found was they would rather do 50 over 360 and then square the 3. And now you could put a 1 under this if you want. So what they wanted to do was multiply 50 times 9, get 450 pi over 360. Now simplify that fraction, which I find is harder because you're going to make more careless mistakes by multiplying those big numbers and then having to reduce. But you can do it this way. So again, I'm going to divide them both by 10, which cuts off the zeros. Then I can divide 45 and 36 both by 9, and then get 5 pi over 4 centimeters squared. Now, I'm going to do the same problem, but I'm going to simplify before I multiply. So if I go ahead and put 50 over 360 times, and I'm going to go ahead and do the 3 squared and make it 9. So I'm going to make it 9 pi I'm going to simplify before I multiply. So again, I'm going to cut off my zeros. And now I'm going to simplify. I can't simplify 5 over 36, but I can simplify the 9 and the 36 and make that 9 a 1 and the 36 a 4. And now I multiply what remains, 5 pi over 4. Same answer I got when I multiplied the really big numbers and then reduced that really big fraction. So area, the units on the answer are always to the second power. So all I'm doing is squaring the units. I'm not squaring any numbers. So just the units are squared for any area problem. Circumference, it was always whatever units were there, not squared. All right, so let's do the 20 now. So for the 20 over 360 times pi r squared, so pi times 9. And again, if you want to multiply it the way it is, this will give me 180 pi over 360, and then I get 1/2 pi. Now, if you want to simplify before you multiply, so you can either write your answer as 1/2 pi, or you could even put just pi over 2, or 1 pi over 2, and make it underneath the 2 underneath the whole thing. Either way, or just put the 1/2 in front. You just can't put the pi in the denominator. All right, so let's do this simplifying. So 20 over 360 times pi times 9. So again, cut off the zeros. I could simplify the 2 over 36. I could make this 1 over 18. And then I can do the 9 and the 18. And then I'm left with the 1 pi over 2. Either way. So 140. So I'm going to do it down here below because I've written in that area. All right, so again, 140 over 360 times pi r squared, which 3 squared is 9. Again, remember, this circle specifically had a radius of 3. The radius is going to change with each problem, just like the angle measure changes. So again, we can simplify. Now, if you want to simplify the 14 over 36 first, or you could do the 9 and the 36. It doesn't really matter. If you want to do the 9 and the 36, because we've been doing that quite often, then I'm left with 14 over 4 pi, which simplifies to 7 over 2 pi. And again, you can write it like this or like this. So with the fraction and the pi behind it, or with the pi in the top of the fraction. And again, the units, centimeters squared. Same thing on part B. These were centimeters squared. Good?
Is it mandatory to put the centimeters squared?
Example D, this one's 210. So again, 210 over 360 times pi r squared, and my radius was 3, so this becomes a 9. I can simplify. So again, I'm going to cross my zeros, and then I'm going to simplify the 9 and the 36. 1, 4, leaving me with 21 pi over 4. And these are centimeters squared again.
This is the exact question.
So before we tackle this one, let's review what a 30, 60, 90 triangle, the relationship of the sides are. So remember that when you have your 30, 60, 90 right triangle, 30, 60, and then the right angle, the side across from 30 is A. The side across from the 90 degrees is 2 times whatever A is. And then the side across from the 60 is A with square root 3. Now, let's go ahead and see what the question is asking us to do. So it's asking us to find the area of the region that is bounded by segment AB, here's segment AB, and arc AB. So the area they want us to find is this piece right here. The formula that we've been using is to find the area of the whole piece of pizza. So it's that yellow plus the triangle. So in order to find the area of that yellow, I'm going to do the area of the sector, and I'm going to subtract out the area of the triangle. So we need to figure out first the area of the sector, and that's what we did on the previous slide, those 4 examples. So here we're going to take our arc length over 360 times pi r squared, and this time my radius is 6. I need to simplify this. Again, I can cross off my zeros. 12 over 36 is going to simplify to 1/3. 6 squared is 36. And now I can simplify this. 36 divided by 3, and the area of my sector is 12 pi.
Wait, what?
Is simplify the 3 and the 36 and make that a 12. And now 1 times pi times 12 is just 12 pi.
Okay.
All right, now time to deal with the triangle. Remember, the formula for area of a triangle is 1/2 base times height. Notice in the triangle in the picture, which if I pull this out, I have the 120-degree angle. I've got 2 6s here. Now, this is not a right triangle. Notice it's a 120-degree angle here. But if I draw in the altitude and split this and bisect that angle, this angle is now 60. The altitude always forms a right angle. And then this angle over here is 30. So let me just write it up here. So here is the triangle I'm talking about. I've got a 30, and I'll put a 60 up here. 60 and 30. So in my picture, the side across from the 90 was the radius, which was 6. Normally, remember, in the triangle I drew up at the top in yellow, this is my hypotenuse, so this equals 2 times A. So if I solve 2A equals 6, A equals 3. And that's the side across from the 30, which is my altitude. So my altitude here of this triangle is 3, and the side across from 60 is 3 square root 3. Now remember, in this triangle, I've got a 3 square root 3 here and a 3 square root 3 here. So my base is 3 square root 3 times 2, or 6 square root 3. My height is 3. So to do the area of the triangle, 1/2 base times height. So 1/2 6 square root 3 times 3 gives me 1/2 18 square root 3, which equals 9 square root 3. So now I'll come over here, and I'm supposed to be filling it in underneath here and subtracting it from the area of the whole sector. I cannot subtract something that does not have a radical, so this would be my final answer if I was not using my calculator.